Hello everyone, welcome to my YouTube channel. So in this video we are going to look at the concept of differentiation of parametric equations. Alright, so what is a parametric equation, or what are called parametric equations? When you have, suppose we say here y is a function of t and x is another function of t, so both of them, that is x and y, are functions of a third variable. So when you have such case, then you say that those two functions are parametric equations. For example, if y here is equal to, let's say, cos theta, and x is equal to maybe 3 cos theta now. So sorry, maybe 3 sine theta. Let's not use this. X is equal to, let's say, 3 sine theta. Okay, so even though 3 cos theta would have also been a good example, right? So we said that these two functions, y and x, are parametric equations, and theta, which is a third variable, is called their parameter, the parameter of the parametric equations. Okay, so if we want to find a derivative of x with respect to y, having a third variable as their parameter, then we say that dy dx is equal to dy dt all over dx dt. And how did you get this? You know that if you have dy with respect to t, that means differentiating y with respect to t, and then you divide it by dx dt. Of course, you see that by normal fraction, this is going to give you dy dt multiplied by, if you change this division into multiplication, it simply invert the next fraction, and that will now give you dt dx. And so at this point, you can easily cancel out the dt, and that will now give you dy dx. Okay, so that's how this gave us this particular relation. So whenever you're given parametric equations, all you need to do is differentiate the two equations with respect to the parameter, and then you now bring it together into that formula. So let's look at this example. Example 1 here says that we should find dy dx if y is equal to this and x is equal to this. Our y is equal to 6, and that means our dy dt is going to be equal to, we differentiate this with respect to t, we are going to get 6 cos t, then minus 1, you differentiate 1, you get 0. And then what is our t? Our t is x. Our x is equal to, so that means that our dx dt is going to be equal to minus 3 sine t, okay, as our dt. So bringing everything now into our equation, which says that dy dx. So if you substitute now, we will have our dy dt is 6 cos theta, cos t, all over our dx dt is minus 3 sine t. Okay, so, and that's going to give us, of course, 6 will be divided by 3 to give us 2. And so we're going to have minus 2 cos theta all over sine theta is equal to cot theta. Cot t. Okay, and so this is our solution. You can use a bracket to separate this. All right, so that's the answer for example 1. So we go over to example 2. 2 says the same thing. We are given two parametric equations. Okay, so we begin by differentiating what dx dt, and that is going to give us, you differentiate 2, you get 0. Differentiate 3 cos t, you will get minus 3 sine t. Dy dt is going to be equal to, okay, so that means that our dy dx, which is equal to, so if you substitute here, dy dt is 3 cos t all over minus 3 sine t, and that is going to give us, of course, this will go, and that is 1. So we have minus cot t, because cos x all over sine x is equal to minus cos t. So these two examples are very close to each other. So we go to the next one, example 3 here. What are we given? So here we have that our y is this and our x is this. So let's begin with getting our dy dt. Dy dt is equal to, this is a quotient. So we are going to use the quotient formula or the quotient rule, which says that dy dx is equal to v du minus u dv all over v squared. Always remember this. So what's our v here? Our v is 1 plus t squared. Okay, so multiplied by the derivative of this. If you differentiate this, you're going to have 2 will come down because you're differentiating with respect to t. So every other thing here is a constant. Meanwhile, they said here that a is a constant. So 2 will come down. That will give you 4at. Then minus under here, now we will now differentiate u. You bring down u, which is 2at squared. Now multiply by the derivative of v. If we differentiate v here, 1 will come to 0, and this will give us 2t. So we'll have 2t here. So that's all over the square of this. Okay, so, and what is this going to give us? We'll try to simplify. If you open this bracket, 480 will multiply 1. So we'll have 480. 480 will multiply t squared. And that's going to give us plus 480 cubed. And that is minus, this one will open. And so you're going to have 480 cubed also. All over the square of this, which is 1 plus t. So what about dx dt? So our dx dt is going to be equal to, what is our, it's the same quotient. So what is our v? Our v is also 1 plus t squared multiplied by du. Du here is a constant. A is a constant, 2 is a constant. So if you differentiate, you have 0 minus that u, which is 2a, into the bracket of, you differentiate this, you have 2t. And that is going to give you over, and this is equal to, here we will have 0, and so this is going to give us minus 4at, and that is all over. Alright, so having gotten this, we can then go for our dy dt. Sorry, our dy dx. Our dy dx is equal to dy dt, which is the whole of this. That is, okay, sorry, we didn't finish this. Look at this. This can take away this, and so you are going to have 4. Okay, so the whole of this will be our dy dt, which is 4at all over, then divided by your, remember the formula, dy dt all over dx dt. So divided by dx dt, which is minus 4at all over. And so if we change this into multiplication, we are going to have 4at all over 1 plus t squared, all squared, multiplied by, this is going to invert, so we'll have 1 plus t squared, all squared, all over minus 4at. So what happens there? This is going to take away this, and 4a here will cancel 4a. In fact, t will also cancel t. So you only have 1 left up and 1 left down, plus minus sign. So your answer is negative 1. Therefore, our dy dx is equal to minus 1. All right, and that's the solution to that example. And so finally, we take the last example here, which says that if you are given these parametric equations of a parabola where x is this and y is this, show that dy dx is equal to t raised to power minus 1. Okay, so what is our dx dt? You will get 2pt, and you differentiate y with respect to t, that's this one, and you will get only 2p. And so if that happens, it then means that our dy dx which is equal to dy dt divided by the dx dt, which is 2pt, and this will simply give you, this will take away this, so you have 1 all over t, and 1 all over t is simply equal to the t raised to power minus 1. Alright, and these are examples we have for derivatives of parametric equations. Okay, kindly differentiate your y with respect to t, differentiate your x with respect to t, and then take the quotient of the two of them. Please kindly subscribe to our YouTube channel, like, comment, and share our YouTube videos. We will see you in our next video. Bye.